Okay, after calculating the radius and the speed of electron in Bohr's atomic model, the last part is to calculate energy. And in this topic, we are going to take the ready-made results of the previous two derivations. What is the radius of Bohr's orbit? N square h square by 4 pi square m k z e square. And for speed, the equation is 2 pi k z e square upon nh. Now, calculating the total energy, we have to calculate the kinetic energy as well as the potential energy. So here it is, calculation of kinetic energy, half mv square. Put the value of v, square it and put over here. What you get is 2 pi square mk square z square raised to 4 upon n square h square. Potential energy, here we are talking about the electrostatic potential energy. What is the equation? K q1 q2 by r square. Sorry, K q1 q2 by r. K electrostatic constant, q1 is a charge of nucleus, Ze, q2 is a charge of electron, and I will put a minus sign over here because in kinetic energy, minus sign, that does not matter, but potential energy can have positive and negative sign, and each sign has its own meaning. So here I am putting the charge of electron as minus E upon r. Put the value of r from this equation into here, and what you get is this. Finally, the equation for potential energy after solving this is minus 4 pi square mk square z square e raised to 4 upon n square h square. Now, finally, adding up the potential energy and the kinetic energy will give you the total energy. That is again addition of this equation with this equation. See, most of the terms are same. Pi square, m, k square, z square, e raised to 4, n square, h square in the denominator. Here also n square, h square in the denominator. Except these two numbers. Here it is 2, here it is minus 4. Okay, so the things are a bit long, they are a bit complicated because there are many different physical quantities coming in the same equation. Total energy is minus 2. इन दोनों को आप जब ऐड करेंगे तो टोटल एनर्जी मिलेगी. ओके, अब जब आप टोटल एनर्जी, पोटेंशियल एनर्जी और काइनेटिक एनर्जी की इक्वेशंस व्हेन यू कंपेयर देम, यू विल सी दैट देयर proportion of kinetic energy to potential energy to total energy is 1 is to minus 2 is to minus 1. Alright, now the thing is the total energy of electron is negative. What do you mean by this? Total energy of electron is negative. In class 11th, we have calculated the total energy of revolving planet. That was also negative. Negative total energy means bound state. So here the negative total energy of electron represents that the electron is in a bound state. It is not free to move, it is bonded to the nucleus. Alright, now I will use this equation of total energy, and separate out the constants and variables. 2 pi square m k e square and h square, these are all constants. What are the variables? Only z square and n square, z square and n square. And what remaining constants are? Their fixed value is minus 13.6 electron volt. So from here, if you want to calculate the total energy of electron for any atom, put its atomic number over here. If electron is in the nth orbit, put the orbit number or principal quantum number over here, and you will get the energy of that electron. Now, special case for hydrogen atom. For hydrogen atom, put Z is equals to 1, and this is what you get. Energy of electron in hydrogen atom in the nth orbit is given by this. So if in hydrogen atom electron is in the first orbit, n will be equal to 1, energy is minus 13.6 electron volt. In the second orbit, n is equals to 2, so you will divide this by 2 square, and what you get is minus 3.4 electron volt. In the third orbit, 3 square, divide this number by 3 square, and minus 1.51 electron volt. Similarly, you can calculate the energy of electron in any atom in any orbit.